So again, in handout 1, we're going to talk about correlations, this time when the independent variable is dichotomous, when it has just two categories, like sex, male and female. Now, again, you have to go back and look at how things are coded. Males are 1, females are 0. So that's important to remember. So let's see here. We have to understand about correlations with a dichotomous variable is the correlation compares one group to another. In this case, my zeros and ones. And as I mentioned, males are coded as 1, females coded as 0. So if I look at, say this is a pretend data file, it's smaller than you turn in, but the idea is the same. So if this is my variable called sex, and these people, these are ones here, well, those are males. So every time you had a male fill out your survey, you didn't write male, you wrote the number 1. How do you know that? Well, again, you go back and look at the coding. That's what I'm telling you right here for this data file. You'll have the same thing for your data file. You turn the coding into me. So the correlation here, I think a way you can start interpreting it is start with the phrase compared to the zeros. Now what does that mean? I'm sorry, let me phrase it. Compared to zeros, the ones are. Compared to zeros, what are the ones doing? What were the ones saying? Well, the sign tells you that the ones were on the lower end of the rdrunk variable. How do you know that? Well, the sign here tells you about the ones compared to zeros, how the ones answered this question. Again, sex is a variable with two options, 0 and 1. rdrunk, as we saw in the last screencast, I'll take you back up here, rdrunk is coded on a scale of 1 to 4. 1 being never and 4 being frequently. So let's pretend that these are the data right here. So here I have my ones, and here I have my zeros. What do you notice about the pattern of how the ones answered this question versus how the zeros answered this question? Because remember, correlation tells you how one variable, sex, is related to another variable, how often you got drunk. So what we're seeing here is that if you look at the answers, these are all men. If you look at the answers they gave in the rdrunk, how often did you get drunk? 2, 3, 3, 3. So if you go back, look at the coding, we're talking about up here, we're talking about a rarely and then some occasionallys. So this male said he rarely got drunk. He said they got drunk occasionally. Okay, look at the women, what they say. You have it frequently, occasionally, frequently, occasionally. So the ones, if you say, this isn't quite the way to do it, but if you average up the answers they gave on this variable here, this average here will be lower than the zeros. So if you go back, look at the output, scroll down again. That's what the negative sign is telling you. The negative sign is telling you how the ones, compared to zeros, how the ones answered this question. If the number were positive, then what you would see, let me make a quick change here. What you would see, move this up here, and this down there. If the number were positive, this is what you'd see, because the ones, the males, would have been a little higher here. These numbers on average are higher than these numbers here. But that's not what we saw. What we see is it's a negative number. Now, before I forget, if you look here, is there an asterisk? No asterisk. So what that means is there's no significant difference between how much men and women get drunk. If there were an asterisk, it would mean there's a significant association between what your sex is and how much you got drunk. So when you present your research, make sure to say that if these are the data, that the output here, there's no significant association, but you still have to explain it. So when you're explaining this one up here, you'd explain the more your peers get drunk, the more you get drunk. And you would also add, it's a significant association because of the asterisks. There's a significant difference. You know, picture, let's see, an example of a significant difference or not. Let's say that you work for me in a factory and I gave you a 10-cent an hour raise for Christmas. You know, it's 10 cents an hour, right? Is that a big deal? No, it's not significant. It's a difference. 10 cents an hour more is a little more, but it's not significant. That's what the no asterisks mean. There's something going on, but it's not significant. So tell us, one, if the association is significant or not. Just look for an asterisk. No asterisks here. You would say that the relationship between sex and getting drunk is not significant. But then you'd interpret, you still have to interpret what this number means. And again, the way you start your phraseology, you'll see this in the description of the assignment, the way you start your phraseology is compared to the zeros, the ones are. The ones are what? Well, let's see. The ones are negative. The ones are lower on this scale. And that negative sign tells you how the ones responded to this question. You have the question, what's your sex? You have the question, how often did you get drunk? So the ones, the sign tells you about the ones. So compared to zeros, again, who are my zeros again? Go back up and look. My zeros are females. So compared to females, males are, the sign was negative, males are lower on this scale. This is the getting drunk scale. What does that mean? Well, lower, the negative sign means lower. Lower means they're down here. Higher would mean they're up here. So if you go back down here, you can see, oops, a little more, there's a negative sign right there. That's what the ones were lower on the getting drunk variable than the zeros. Who are the ones? Men. Zeros, women. So compared to women, men are on the lower end of the scale. What's that mean to be on the lower end of the scale? Go back up and look. They were more likely to say they didn't get drunk. So if this little number here could talk, it would say this is not a significant association, but men get drunk less than women. So we'll keep going over examples of these, but that at least is how you would interpret a correlation where one of the variables is dichotomous.